Hello ladies and gentlemen, my name is Morgan. I am the proud holder of the Cisco Certified Network Associate certification and the CompTIA A+ certification. These certifications confirm that a holder has an understanding of computer and printer hardware, software, troubleshooting, customer service, and Cisco routers, switches, routing protocols, and the Cisco iOS system. I was educated at a local community college by a team of Cisco certified professors in how to operate Cisco routers, switches, and how to understand Cisco routing protocols in preparation for my Cisco certification exams. My education also granted me access to Cisco's Net Academy training program and Packet Tracer, which is the program that we see here. Packet Tracer will allow us to create a simulated network environment so we can experiment with Cisco-based hardware and routing protocols. Over the course of this video series, I'll be demonstrating some of the skills that I was taught, including the basic configurations of Cisco routers and switches, how to secure these devices, how to configure IPv4 addressing and subnet masking, how to establish VLANs, trunks, and inter-VLAN routing, how to configure static routes, dynamic routes, how to establish a dynamic host configuration protocol for multiple hosts, and how to install access control lists. In this video, we are going to focus on configuring Network 1, which is our single VLAN network. Network 1 will consist of 3 PCs, 1 router, and 1 switch, all confined to a single logical network. This is the type of network we might find in a small home or office. Network 1's IP address will be 190.100.10.0. It is considered a /24 network, which means its subnet mask will be 255.255.255.0. This means that Network 1 will be able to have that addressing scheme assigned to up to 254 devices, including PCs, switches, and routers. We'll start by configuring each of the PCs with an IP address, and we'll make sure that all of them share the same subnet mask. We'll assign the last 3 available host addresses to our PCs. In this case, PC1A will be 190.100.10.252. The subnet mask of 255.255.255.0. PC1B will be 190.100.10.253. And our network PC, our admin PC, will be 190.100.10.254. We can't use 255 as a host IP address because that will be considered our network's broadcast address. And now we'll test to see if these computers can communicate with each other. We'll go into a command prompt and we will attempt to ping one of our neighboring PCs. And we are successful. Try to ping PC1B, and we are successful. So, all of our PCs can communicate in this switch-based environment. Now we're going to assign a very basic configuration to our switch to allow our PCs to communicate with said switch. To do this, we'll need a special cable called a console cable or a rollover cable that we'll use to connect our admin PC to our switch, like so. We can then access our terminal window to apply configuration to the switch from our admin PC. Now that we've accessed our switch, we will assign it with a basic configuration. Our basic configuration will include a host name for the switch, a message of the day which will greet any user attempting to access the switch, and we will assign an IP address and a subnet mask to its VLAN 1 interface so our PCs can communicate with the switch. To do so, we'll have to access Global Configuration Mode. Our hostname command will allow us to assign a name to the switch. Our banner MOTD will allow us to create a welcome message, which will discourage any users that unauthorized access is prohibited. And our interface VLAN 1 command, along with the IP address command, will allow us to assign an IP address to our switch. We'll activate the interface with the no shutdown or no shut command. And after exiting the switch's configuration modes, we can see that our banner has taken effect, our device name has been installed, and we will now attempt to ping our switch from our PCs. PC 1A can communicate with our switch. PC 1B can communicate with our switch. And our network admin PC can communicate with our switch. Now for our network's basic configuration, we're going to assign an IP address to the interface that is closest to our network on Network 1's router, in this case Gigabit Interface 01, and that's going to serve as our network's default gateway for when we want to have our PCs communicate with the rest of the network beyond this router. To do this, we'll take our console cable, we'll plug it into our Network 1 router, like we did our switch. We will access our router using our terminal emulation application, much as we did our switch. We will access global configuration mode, and with our interface gigabit 01 command, we will access the interface that we need to assign an IP address to in order to serve as our default gateway. Our address will be 190.100.10.1. Subnet mask will be 255.255.255.0. With our no shutdown command, we'll activate our interface. And we'll check to see if our PCs can ping our default gateway. Alright. There was a momentary delay because our switch was still resolving the router's MAC address. And now that that's been taken care of, our PCs can communicate with our default gateway address. Now this does not necessarily mean that these PCs will be able to communicate with the rest of the network with this configuration only. There are a few more steps we need to do. But for now, all three PCs can communicate with our router. In preparation for our Network 1 communicating with the rest of our network beyond the Network 1 router, we need to distribute our default gateway address to our PCs and to our switch. To do this, we'll access our PCs. We'll simply plug in our default gateway address to each of our IP configuration menus. And there's a special command that we need to input on our switch in order to have it recognize the default gateway. So we will access our switch. And the command is simply IP default-gateway. And we plug in the IP address of router 1's gigabit 01 interface, like so. We won't notice any changes even when we ping the default gateway address, but we would notice them if the rest of the network was configured and we attempted to ping a PC beyond router 1. To finish the job, we will apply the rest of our very basic configuration to our Network 1 router. Now that our router and our switch have their very basic configurations applied, we need to work on securing their modes of access. To To do this, we'll access our router one more time. We'll access global configuration mode. And what we'll need to do is we'll need to secure each of their lines. We'll need to apply a password to the console port, which is what we're connected through right now. And we'll need to apply passwords to their virtual terminal ports, which allow a device to be accessed remotely. We will install a password to our console port. We'll have it prompted at login. And we'll install a timer, which will forcibly terminate a user's access to the console port after 2 minutes of inactivity. We'll secure our virtual terminal lines with the same commands. And we'll see if they've taken effect. We're prompted for a password upon initial login. Upon entering the password correctly, we see that it has taken effect. This isn't all we can do, however. We need to assign passwords to protect our privileged levels of access to our router. To do this, we will access our router. We also need to assign a special service to encrypt our passwords. Without it, our passwords in our running configuration will be displayed in plain text for everybody to see. We have two options. We can either enable a password in plain text, or we can enable a password that's encrypted by default. It's preferable to use the enable secret command. If you first enable a password, and then assign an enable secret password to protect privileged executive mode, enable secret will take over as priority. To encrypt our passwords that are displayed in plain text, we'll use a special service password encryption command. Once this service is applied, all of our passwords will be encrypted. We're prompted for a password upon console access. And we're prompted for a password upon attempting to access privileged exec mode. And our password has taken effect. We'll do the same thing for our switch. Upon looking at our running configuration, it seems that our switch does not have any passwords configured to protect its console port or its virtual ports. We're going to fix that. Our console port and our VTI ports have been protected. Now we need to secure our switch and our router's means of remote access. When you access a Cisco device by remote, you have two means of connecting to it, Telnet or Secure Shell. Telnet transmits all of its commands in plain text and is considered less secure than Secure Shell. Secure Shell is entirely encrypted and is considered the preferred method. To configure Secure Shell on our switch, we first need to establish a domain name. We need to install a crypto key. And now we need to configure local administrative credentials with a maximum privilege level of 15 and a password that is encrypted by default. We can then configure Secure Shell for version 2 access only, with 2 login attempts before the session is terminated. And we can install a timer that will forcibly terminate a session after 2 minutes of inactivity. We'll now secure our virtual terminal lines, and we will allow secure shell access only, while comparing the remote access to the local credentials on the router itself, and we'll allow version 2 of secure shell only. With all the commands that we've been entering so far, we need to save our running configurations, so that if our switch or our router loses power, all this information will not be lost. Like so. We'll do the same thing on our router. We're now going to implement port security on our switch. Port security can protect our switch from devices that the switch does not recognize, including forcibly shutting down the interface when a device that the switch doesn't recognize is plugged into it. We're going to be working with fast Ethernet interfaces 01, 02, and 024 since they have devices attached to them. And since we're working with a lot of interfaces, we're going to add descriptions to each of them. We're first going to configure our port security to learn all of the device's MAC addresses dynamically once they are connected to the switch. We will limit each port to allow only one device, and we will issue the command to have that port forcibly shut down in the event a device the switch does not recognize is plugged into it. Shutdown mode is the default mode for port security. We're now going to secure the ports which do not have devices plugged into them, but instead of doing it one by one, we can configure a range of ports with the range command. We'll turn them into access ports, and we'll forcibly shut them down. We can secure these ports even further by assigning them to a VLAN which leads to nowhere. To do this, we simply create a VLAN with our VLAN command. We assign it an erroneous number, in this case 999. We'll name it, in this case, black hole. Then We will access our ports which are empty. We will assign them to our black hole VLAN. And we will inspect our configurations. Our empty ports have been assigned to our VLAN that leads to nowhere. So even if a device is plugged into this switch through an empty port, that device will not be able to access the switch. Now that port security has been enabled, we need to ping all of the devices that are connected to the switch to ensure that these devices' MAC addresses are stored in the switch's MAC address table. PC1A has been stored. PC1B has been stored. And the network 1 admin PC has been stored. If we are successful, we will see the MAC addresses of these devices in our running configuration. And we are successful. I've noticed that I've accidentally shut down the port connecting to my router from my switch. This is why it pays to check your running configuration. No problem. We can fix this easily. Furthermore, we will ping the router, so we add that router's MAC address to the switch's MAC address table. We'll wait just a moment while translation is resolved. And there we have it. Our router's MAC address has been added to the switch MAC address table. Looks like I've forgotten some things with Gigabit Interface 02. That's better. We'll now test to see if we can ping all the devices on network 1. We can ping all of our devices. We'll now attempt to access our switch and our router remotely. We can access our router remotely. Let's try our switch. We can access our switch remotely. Network 1 is officially configured. In our next video, we'll be focusing on configuring Network 2. This will involve intra-VLAN routing, multiple VLANs, and trunking protocols.